Welcome back to Ramseyland. Today I want to show you how thermal expansion and the reduction of air pressure can cause a candle to rise in a solution of water at different rates. Check this out. All I'm using in this demonstration is a tray of water, 2 candles, a couple glasses, and a lighter. Okay, chances are you've seen this demonstration before. I've lit both candles and they're floating in a tray of water. I'm going to cover one candle quickly with a glass. Watch what happens to the flame. The flame starts to run out of oxygen, and when that happens, look at the water level. It starts to rise in the glass. Think about, why is that happening? Now the second candle over here, I'm going to use the same size glass, but I'm going to do something different. I'm just going to kind of hover the glass over the flame for a minute, and I'm allowing the air inside the glass to warm up. And then I'm going to cover it, just like I did the other. And you'll see that the flame goes out, but look at the water level. Look how much higher it rose. Now the candle's up to here, but in the first glass, the water level's down here. So why did the water level rise higher in this glass, but not as high in this glass? If they're both the same size and I'm using the same candle, what happened over here that made the water rise higher? Think about that. So what you're seeing here is a combination of thermal expansion and air cooling and contracting as it does so. So in this first one, we didn't hold the glass over the flame for very long. We just covered it very quickly. And so the air inside was heated by the flame that kept burning for a few moments. And when the candle went out, the air started to cool and it started to contract. And that created a vacuum that made the water level rise. But the second glass over here, we just held the glass over the open flame for a few seconds, allowing the air to really heat up and to expand. And some of that air was forced out of the cup. And then when we covered it, the rest of the air that was left in the cup, again, it started to contract and cool when the flame went out. And that again created a vacuum. But there was less air in the second cup to begin with because of thermal expansion. We just held it over that open flame. And as those molecules got warmer and warmer, they expanded. And as they expand, they pushed air out of the glass before we submersed it in the water. That's why this one had the water level rise higher than this one. I hope you enjoyed today's edition of Ramseyland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.